Amino acids are monomeric units of proteins. That is, they are the basic units of proteins. There are 20 standard amino acids, and these amino acids, we call them alpha amino acids. All the amino acids except proline are called alpha amino acids. Now, they are called alpha amino acids because they have the carboxylic group and the amino group on the same carbon. That is, the carboxylic group and amino group are attached to the same carbon, and that carbon is the alpha carbon. Now, look at what I'm talking about. This is the typical structure of amino acids. This is what I said. This is the alpha carbon. The alpha carbon has the carboxylic group and the amino group attached to it, and this is why amino acids are called alpha amino acid. Now, I said proline is an exception because, okay, let's have the structure of proline. Proline is an exception because proline has the amine group. Proline has a amine group attached to the side chain of the amino acid. In fact, it is first called amino acid, not even amino acid. Now, take note of something else. In normal or other amino acids, we have a primary amine. This is an amine group, a primary amine. But in proline, we have a secondary amine. Now, what makes it primary and secondary? A primary amine has forms a covalent bond with only one carbon. Notice it has only one carbon attached to it, forms bond with only one carbon, while a secondary amine forms covalent bond with two carbons. So in other amino acids, we have a primary amine, and we have the amine group and the carboxylic group attached to the alpha carbon, and so they are called alpha amino acids. But in proline, we have a secondary amine, and the amine group is even attached, like forms part of the side chain. So proline is an exception here. Let's consider the properties, the general properties of amino acids. The first one we're going to talk about here is existence as sweeter ions at pi, and pi here means isoelectric point. All the amino acids have a particular pH at which they have both negative and positive charge, and as a result of this, they don't have a net charge. They don't have a net charge because there is positive and negative charge present in the amino acid, and this occurs at a particular pH. All the different amino acids have that particular pH where they exist as sweeter ions. That is that pH where they have both negative and positive charge, and as a result, they don't have net charge. That particular pH is called the isoelectric point, and at this point, the amino acid becomes insoluble. Now, when amino acid has both the negative and the positive charge, when amino acid has both the negative charge and the positive charge, we say the amino acids exist as sweeter ions, and this occurs at the isoelectric point. And like I said, every amino acid has its own isoelectric point. That is the point where it has both negative and positive charge, and as a result has no net charge. Okay, the next property of amino acid here, we have peptide bond formation. Two amino acids can form a peptide bond, and this involves elimination of a molecule of water. So therefore, amino acids can actually polymerize by formation of many peptide bonds. Now, let's see how a peptide bond is formed. We have let's say we have an amino acid, we have another okay. I'm trying to manage the space. I'll make it tiny so that remember I said amino acids form peptide bonds. Two amino acids can form a peptide bond, and this occurs, this is a condensation reaction, and a molecule of water is given off. This is a peptide bond. This is a peptide bond, and like I said, a molecule of water is given off. If you notice, the reaction actually occurs between the carboxylic group of amino acid and the amino group of the next amino acid. Okay, if you notice something, let's have let's say we take two hydrogen molecules from here. We have the two hydrogen, and we take one oxygen from here. We have water, and the remaining oxygen gives us this. Let's see it in that way. So this is formed. This is a peptide bond. Amino acids can actually form many peptide bonds. That means many amino acids can polymerize to form polypeptides. The characteristics of amino acids. The next property of amino acid we're going to consider is optical activity. When we say a molecule is optically active, it means the molecule can rotate a plane of polarized light either to the right or to the left. Molecules that rotate plane polarized light to the right are distro-rotatory. Then those that rotate to the left are molecules that rotate plane polarized light to the right are distro-rotatory, while those that rotate to the left are levo-rotatory. And these are both called, they are enantiomers. They are enantiomers, and they are mirror images. Now, a solution that contains both the distro-rotatory and the levo-rotatory form of a molecule is called a racemic. For a molecule to be optically active, it must have a chiral center. What is a chiral center? A chiral center is a carbon that has the carbon that is tetrahedral. That means it has 4 different groups attached to it. If you look at the structure of the common amino acid, you notice that the amino acids, let's see, the amino acids have 4 different groups attached to it, and of course there's an exception. The exception we have here is glycine. Glycine does not have a chiral center because the carbon does not have 4 different groups attached to it. this is hydrogen and this is hydrogen. So glycine is off. Glycine is off. Now, apart from glycine, all the amino acids are optically active because they have chiral centers. Yes, they have at least one chiral center. Like I said, apart from glycine, all the amino acids have chiral center, therefore they are optically active. I remember what I said about being optically active. That means all the amino acids except glycine can rotate a plane of polarized light either to the right or to the left. I remember the features projection, the D and the L amino acids. The next property of amino acids we're going to discuss is the R chain. We can identify amino acids based on their side chains, and because they have different side chains, we can classify them too. Now, let's classify amino acids based on their polarity. I classified amino acids here based on polarity as I have non-polar amino acid, then I have uncharged polar, and I have charged polar. It's more like saying amino acids are classified into non-polar and polar. Then under polar we have charged and uncharged polar amino acids. Okay, let's talk about the classification right now. Let's talk about non-polar amino acids. There are about 9 non-polar amino acids. How do you remember them? I'm going to give you a mnemonic. I use the mnemonic VAM girl PT. Remember why they are called non-polar? That is, they are hydrophobic. So remember vampire movies, how you get scared when you watch vampire movies. So I just use that to get in money, VAM girl PT. Now, I said there are 9 non-polar amino acids, and I have valine, alanine, methionine, proline, glycine, isoleucine, R is out of it. I have leucine, phenylalanine, and tryptophan. Once again, the non-polar amino acids are 9 in number. They are, remember the mnemonic, I said vamp girl PT. I said valine, alanine, methionine, proline, glycine, isoleucine, leucine, okay, sorry, let's come again. I said valine, alanine, methionine, proline, glycine, isoleucine, leucine, phenylalanine, and tryptophan. Okay? For the uncharged polar amino acids, we have about 6 of them. And I also have a mnemonic for that. I said come take this gas. C here is for 16. I have threonine, tyrosine, glutamine, asparagine, and serine. Again, we have 16, threonine, tyrosine, glutamine, asparagine, and serine. Okay, for charged polar amino acids. Now, charged meaning they have either negative or positive charge, more like saying basic and acidic amino acid. Now, for basic amino acid, we have 3 of them. That is histidine, arginine, and lysine. All for the basic amino acid, histidine, arginine, and lysine. Then for the acidic amino acid, I had a mnemonic also. AG baby. Don't mind me, I'm a fan of Adekule Good. So AG, of course you should know, glutamate and aspartate. They are the acidic amino acids. So we can try my mnemonic to remember the non-polar, the uncharged polar, and the charged polar amino acids.